For this portion of the project, we're going to use what are called kinematic equations. If you are in physics, this is going to be nothing new to you. If you've not taken any physics yet, then this will be a nice little introduction. So if a projectile is in motion, then we have to use principles of physics to come up kind of with our mathematical models. And we've seen this already in a similar equation where we've talked about projectile motion in section 3.1. So when an object is launched, there's initial conditions that can be used to answer multiple questions. So the ones that we're interested in are several things, like how high did the object go, how fast did the object move horizontally versus how fast did it move vertically, because those are different, how high did it go, and so because it has both horizontal and vertical motion, then we have to consider these kinematic equations to be able to take all of these things into account. And gravity is also going to affect that motion when we are moving vertically. Horizontally, gravity is going to have no effect. Like when you run side to side, gravity is not doing anything other than keeping you on the ground. But if you were to jump, the height that you can jump, that is going to be affected by gravity. So we're going to be focusing on three kinematic equations here. So we're going to be looking at kinematic equations for distance, for height, and for the vertical velocity. Okay. Now, don't get overwhelmed by this because each of these variables just stands for something specific that's going to be information that you are given in the problem. So for distance, the horizontal distance, that's why we're calling it x, is going to be the horizontal velocity, that's Vx, times t, plus the initial starting position, so the initial horizontal distance. Remember, we talked about anytime you see that sub-zero, that's always talking about an initial condition. And again, these terms are all defined over here. So Vx is our horizontal velocity, and then x sub 0 is our initial starting position. Okay. The second equation is going to be for height. Now this one looks a lot more similar to that projectile motion problem that we looked at. Okay, so our vertical distance, aka the height, is going to be half of g, and g is going to be the acceleration due to gravity. So these are the values that we are going to use for this project. Negative 9.81 meters per second squared, or negative 32.19 feet per second squared. The reason acceleration is in units per second squared is because like your velocity would be in, let's say, meters per second. Acceleration is how your velocity is changing. So it's how many meters per second changes per second. So it's meters per second, and for simplicity, we write that as meters per second squared. And so again, check out all of the key there on the side so you can see what these things stand for. So G is our gravity, T is time, this Vy sub 0 is our initial vertical velocity. The Vy is to tell us that we're looking at the vertical velocity, and then the 0, again, always tells us that it's initial. And then simply y sub 0 is our initial position, which vertically would be our initial height this time. Now, if I want to calculate the vertical velocity, which we are interested in, then we are going to use this equation. Vy, again, that's the velocity with respect to y, so that's our vertical velocity, is equal to the initial vertical velocity plus gravity times time. And that is how we will determine our vertical velocity. So we're going to use those equations. When I worked this out, I copied those three equations down kind of on a piece of scratch paper so that I had them next to me as I was working, so I didn't have to keep flipping back and forth in my paper. So we are going to look at example 1 and example 3 together today. And then you will be responsible for working examples 2 and examples 3.